Welcome once again to the lecture 33 of the course titled Underground Mining of Metalliferous Deposits. Here we will learn one stoping method. It is called stope and pillar method. This usually you will not hear the name of stope and pillar, but very rarely this name is used. The most common name in India is actually room and pillar, but what I found that this room and pillar has a different method of working in other parts of the world. So, to avoid confusion, taking the help of one author, now I have decided that we will call it stope and pillar. This is one of the simplest method to understand, but here you will definitely require the basic understanding of the development of metal mines, like the drives, cross cuts or drifts. Now, many people call it drifts. So, what is the drive, how the drive is made, how the cross cuts are driven, and what are the different methods of raising, because these drives and raises, a combination of these two, this makes actually the stopes in this particular method. And the ventilation and safety of development headings that you must know, because this is highly development oriented and faster development is the essence of this stope and pillar. So, you must understand the ventilation and safety, how to improve the standards, and elementary rock mechanics, that means the support part, that you must have the knowledge. Now, the objectives as usual, that you will be able to understand the one of the methods of the underground hard rock excavations here, and also in every methods that we describe here, that we will have the knowledge of different unit operations associated with that particular method, how the drilling, blasting and support system, how the ore will be taken out, how it will be transported, how it will be taken out of the mine, like that, and related safety environmental issue will be always discussed, whether backfilling is required or not, that also will come to know. So, definitely we will be able to understand from this lecture that, or the entire course, that you will be knowing a good amount of knowledge you will acquire in regard to the applicability or selection of an appropriate mining method. So, whether this particular stope and pillar method that we are going to learn today is applicable in certain situation or not. So, when you learn things in detail, the applicability will be very easy to understand, and what is the technical feasibility, whether this is a feasible method or not technically, and safety, standard of mechanization, whether how to improve the standard of mechanization, how to improve the productivity, is there any chance, is there any scope to do that. So, that we will be able to understand, right. And this course will also help the participants for implementing different development and stoping methods, that is the basic idea. So, that they can act as not only as a planning engineer, but also can become a very good mine manager in their professional life, that is also the idea. Now, the text and reference books out of this, the SME handbook and also the book by Hustrulid, as I am repeatedly telling that the book by Hustrulid, that is very important for understanding the underground metal mining. Now, what is the specific objective of this particular lecture? What is the specific objective? The objective is to understand the stope and pillar method of ore extraction and the applicability of this method, and also in this particular lecture a detailed account of stope development. Actually, this particular lecture is divided into two parts. So, first one we will go for stope development, the basic ideas about the applicability of this method, and step by step how to develop the the area or mining block for the purpose of the extraction of minerals. That is the part 1, and in the next lecture you will be learning how to go for step by step mining through a stope and pillar method of ore extraction. Now, what is this stope and pillar? As you have already seen the brace stoping, that means we start from one raise from left or right, and we go on mining and leaving in between some pillars wherever is necessary, right. Now, in stope and pillar method is basically a variant of this breast stoping, and it is much more organized and much more defined, and it is much more systematic compared to what we have learned in breast stoping. So, what is this actually? This is a series of short span stopes. These stopes are not very wide, maybe 10 meter or 15 meter wide stopes that you will very soon see, and separated by what? Mined material, extracted across the horizontal plane. So, these stopes are actually separated by the mined material, which is extracted across the horizontal plane, and creating horizontal arrays of rooms and pillars. What we are actually doing, that these are actually horizontal arrays, that means a series of stopes one by one in one level, one by one. There will be these stopes are nothing but rooms, since we are not calling room and pillar. So, there will be stope, then there is a gap, a barrier pillar, and then there will be another stope. There will be a series of stope and pillar like that. So, to do this, these rooms of ore are dug out, while pillars of untouched material are left to support the roof overburden. That means, when you are widening a particular area, then it will try to collapse on its own weight. So, how to stop that? What we do? We leave pillars from upper level to lower level continuous like a rib, and that acts as a continuous pillar from top to bottom, and that supports the hang wall, which rests on the footwall of the load. And this to differentiate it from the standard form of room and pillar, we have renamed this as stope and pillar, otherwise it will create lot of confusions. That I am trying to tell you in the beginning. And where is the applicability? When do you select this particular method? So, this method is widely used in many like copper mines, and the width is around very narrow, like 1.5 is good for breast stoping, but from 1.5 to about 4.0 or even 4.5 meter is very good for room and pillar, not more than that. That becomes little bit difficult, that I will come to know. I will come to discuss about these things, why it is dangerous. So, this narrow, but well up to 4.5 meter, not bad. Host rock, that means what is the quality of the host rock surrounding the ore body, where the ore is deposited. So, what is the quality of that? What is the quality of hang wall? It should be moderate to strong. That means, weak hang wall or weak host rock is not good, because it is open stope. In open stope, it is very difficult to keep the hang wall without a support. So, it should be at least moderately strong, or if it is strong, then nothing better than that. And in ore body, what kind of ore body you are going to mine? Weakly moderate, we say. That means, not very weak, but from weakly moderate to strong, all this wide range of ore body we can mine out by this stope and pillar method. Deep, you can start from say 30 to 40 degree. Very steep room and pillars are not workable. I mean, this stope and pillar method, very steep, it automatically falls to the lower level, and it does not provide any protection from accident. So, around 40 degrees fine, absolutely fine. More than that, then you have to take very special precautions, or certain modifications will be required. Some modifications will be required for safe mining. About the temporary support, that this particular method requires some timbers for temporary support. So, these must be available. So, this if it is not available, then it is difficult to work. And backfill materials. So, do you really require, then it is an open stope method, but then why you are requiring backfill materials? Nowadays, the availability of the tailings and its utility for the purpose of support after the mining is over, that has become very popular. And why we require it? Because at deeper levels, when the rock pressure underlying overlying the rock pressures pressure from the upper strata becomes too high, then what we do? We put backfill materials, that means the waste material inside the stope, so that the hang wall settles on it, hang wall does not collapse. So, if you are going for room and pillar stope and pillar mining in deeper mines, then you should be ready with the system, and the tailings for backfilling must be available with you, otherwise this method is not feasible. Now, we are going to see how it just an idea of how it looks like. So, it is an open stope at shallow depth. So, third level, fourth level, fifth level, like in 500 feet I have seen open stope. There is no additional pillar support, nothing is required, even backfilling is not required, but it collapses. That means, if you leave that mine that particular stope after working, then what happens? It collapses. Okay. But if you want to avoid that, and when you know that when one part of the mine collapses, then it can affect the other parts also, because to entire rock mass around the workplace will try to adjust itself to settle on the different kind of forces acting on it. So, what we do that in higher depth, when we have deeper mines, maybe more than 500 600 feet, then we go for backfill type, which is not open, this is filled, completely filled. No pillars are left within the stope. Whatever you see here, that this part within the stope, this is one stope and this is one stope. So, here what we see, we do not leave any pillar inside the stope. What we leave is the rib pillar between two stopes. This is one stope, this is one stope. In between there is a long pillar from top to bottom. That is the only thing that we have. Other small supporting materials will be required, that I will discuss. But then how do you decide what kind of decision we should take, like should we go for open stope or should we go for the backfill type. So, that decision is taken once you have done the proper geotechnical studies, rock mechanics, the analytical part, and then only you decide whether we should go for fillings, backfilling, or we can keep it open, depending on many things, that overall workings in any mine, that you have to decide whether it is going to disturb other areas or not, whether it is going to we are going to see any collapse in the working levels because of the huge movement unfilled stopes can create. So, we have to conduct proper geotechnical studies to take a decision. Now, this is actual little simplified, but I have taken it from one mine. The stope and pillar is a mining system in which a series of open stopes are made from a series of raises connecting two consecutive levels. Try to understand this part, that whatever you see in colors, the red is one level, say fifth level, it is written here fifth level, and then this the upper part is fourth level, like that this is third level, this is third level, the black one, this one, the green one is the fourth level, this is the fifth level. So, these are levels of different of a mine, different levels, and what we have done, we have connected the levels, consecutive levels. Say this is third level and this is fourth level. We have connected with raises 1, 2, 3, like that, numbers of raises, these are raises, and also from say 4 to 5, we have 5 to 4, from 5 to 4, we have 1, 2, 3, 4, like that, a number of raises. Okay. So, here what we do, we have made a series of raises, and we have defined this this part as one mining block. This mineable reserve has been defined as a mining block, that means this is one raise, this is one raise. Now, we can have other raises in between these two raises. So, these are called the block end raises, and this part the mineral locked inside this part, the defined by the upper level, lower level and side raises, we can call it one mineral block. To mine out this, we can have other raises also in between. in between also we can have a series of raises. Okay. So, these raises will be later on converted or rather mined out to form the open stopes. That is the idea of the stope and pillar method. Now, how do I do that? First we divide, as I said, that the mineable ores in blocks. So, these are blocks, this is one block, this is one block, like say here, this is also one block, this is one block, this is one block, like that. And say here we had blocks, this is one block, but what we have done, then in between the block and raises we also had raises here, say this one. So, we have raises like this, these are raises inside the block. So, now this also we can make raises in between also for the raises. Now, the distance we will discuss what will be the distance between two consecutive raises. Now, for for one block, say for one block we have to identify this block, we have to give a number. So, what we do, we give, say by coordinate we can give 1270 to 1370 north block, and in between we can give other names of the other raises also, but for identifying a block we will say it is 1270 north to 1370 north block, depending on the coordinate with reference to a common reference point. Now, these mineable blocks are then developed with block and raises, as I said. So, this one, and in between once this block end is developed, then what we do, number of these raises are made as I have shown in the earlier slide. Now, we make a number of raises in between the blocks. So, this is one block, this part and this part, and we made number of raises in between the two block and raises. This number of raises depends on the design of the stope. That means, what will be the span of the stope? First, that we have to decide, span of the open stopes and width of rib pillars. If we are say expanding this to make one stope, and this side also we are expanding, then what will happen? There will be a rib pillar in between. So, we have to first decide how wide the stopes will be and what will be the size or thickness of the width of the rib pillars. So, combining these two, we will be able to find out what is the center to center distance between two raises. So, I will come to that in this. So, the number of raises, as I said, that will be decided on these two particular parameters. So, each of these raises, when we make a series of raises, then what happens? These raises will act as the center raise for one step. That means, this is basically a single raise stope. The stope depends only on one raise and the upper level and lower level, bus, that is all. Now, what happens? We actually widen the raise on both the sides. So, this raise is later on converted to one stope. So, this every center, all the raises, all these raises will be used to make stopes. So, one raise, every raise rather, each raise will be used as a center raise for the stope that we are going to make. How this is done? The typical span in one of the companies, Indian Copper Complex, depending on the rock mechanics or geotechnical characteristics, that at lower level at shallow depth rather. So, 15 meter span, that means one stope will be 15 meter wide, this part, here it is written 10, I will come to that, 15 meter, and this is rib pillar, this is untouched, this is not used. So, this part is used for the support, this is the upper level, this is the lower level. Now, when you are widening the stopes, then the hang wall will try to collapse, the hang wall will try to come down, because both sides we have actually widened. So, for supporting that, to prevent that, what we have done? We have left this in between this rib pillar untouched, we call it rib pillar. So, here say in this case we can have two options. Say at shallow depth up to 500 feet we have 15-meter span with 4-meter rib pillar. That means, every stope will be 15-meter wide and in between there will be 4-meter rib pillar. So, what we do that from when we plan the stopes or make the raises, then it becomes 15 plus 4, but at higher depth, say when you go for another study, then we see that the stopes should not be wider than must not be wider than 10 meter at higher depth, because then the rock pressure of the overlying rocks will be too much. It will not be able to support the automatically or stand on its own. So, this becomes a 10 plus 3 design at higher depth, but at shallow depth we can have 15 plus 4 design, 15 meter wide, 4 meter rib pillars like that. So, it will be a series of 15 plus 4, 15 plus 4 like that, but at at higher depth we can go for 10 plus 3, 10 plus 3 design, that also is possible. It is not a specific figure recommended for every mine, no at all, not at all. So, this is actually decided by after we conduct any geotechnical study to find out what is the rock pressure, and then only we go for a specific design. Now, here as I said that let us call this one the width is S and the rib pillar width is R. Now, see center to center distance of one raised to the other, is C. So, what we can write that the center to center distance, that means the center line of this raise and the center line of this raise. Then if we measure from center to center, it becomes C, and C equals to S plus R, C equal to S plus R, C equal to S plus R. Okay. S plus R. That means, the stope width and the width of the rib pillar, that is the design. As you know, so this is the lower level, this is the upper level, this is one raise 1, this is raise 2, and in between we have kept a rib pillar. Actually, we are planning to go for widening this stope in future. So, that is the basic idea behind all these things. So, like it will come like this. What we will do that we will not puncture this, at all. We will come here and stop from this side, and we will also come from this side and stop. We will keep the entire rib pillar completely intact without touching it. So, that is how we are going to mine out this particular stope. Now, in these things it is now imperative rather to understand what is the systematic development procedure of this stope and pillar method. One is the lateral development, that means the drives, the drive that you are seeing at the top, the upper level and the lower level. That means the drives you must know the how to make this lateral developments called the drives. So, it is a standard size say 2.4 by 2.4 meter. Connecting raises, this is the connecting raise from the bottom level to the upper level that you can make 2.2 meter by 1.5 meter is one design, but you can change it also. So, location of block and raises is usually decided by adequacy of ventilation in the advancing drives. That means, see if you are when you are going towards this direction, when you are going say we are going inside to this direction, then how to decide that where will be the next raise, block and raises, these are say block and raises. Okay. How to decide these things, but then remember that when you are moving in this direction, then you are actually in a blind area, that means it is not ventilated. So, you are using some artificial methods, a fan duct, those things you are using for ventilating. What we do say after say 90 meter or 100 meter, when it becomes too hot or not manageable, then what we do, we make one raise. What will happen when this raise go and connect with the upper level, then the ventilation circuit is established, ventilation circuit is established, all the raises will provide ventilation. So, when this also reaches connects with the upper level, this also will provide ventilation. So, that is one way of deciding where to put the raises. Once you do that, then you have established say block 1, block 2, block 3, they are ventilated, only the through the raises ventilated. So, ventilation circuit is well established. Now, for the raises that you have to decide depending on the span and the width of the rib pillar, what will be the distance between consecutive raises in between, like that. How many raises you will make, where they will be made, as I said in the earlier slide, that will be decided by the span of the stope and the width of the rib pillar that we are leaving. Okay. Now, see, in further systematic development, the upper level has to advance much faster. This part, no, this part we advance much faster, because unless you these drives, these are drives, line diagram, this is a line diagram, unless these drives they move very faster, where do you make the raises? So, the essential thing is, the condition is that you advance the drives very fast and make space for the the operating people to connect the lower level with the upper level at multiple points, like all this. So, it is a prerequisite that the development is the essence of mining. Unless you develop a mineral block, you cannot make any stope, and unless you make large number of mineral blocks or stopes or mineral blocks ready for stoping, you cannot increase the productivity. Because see, you must have the facility of mining at different points in a level, So, there what we do, that we establish mineral blocks at at faster rates, because whenever we require more production, we can increase the number of steps or stopes, because the mineral blocks are ready. See, all these things when you are ready with this, so you can have 2, 3, 4 as some depending on the planning, you can have number of stopes at a time, which will improve the production, which will increase the production. So, that is the flexibility, to improve the flexibility. So, or improve the productivity, whenever you require more, you can start. You have more manpower, you have more machines, you can increase productivity. It is a very flexible method that way. Now, your next one is the faster development. Say now, say driving, I said you have some artificial the ventilation, some chilled water to cool that area face, and good organization, supervision, you can do this lateral development, faster developments. What about the raising? How to do faster raising? So, when you learned the different raising methods, so you must have understood that ventilation is a major hindrance, major obstacle in raising, because raises are blind. When you are making them, these are all blind, and when you are going up, say from here you have started like this, you are going up, but these are all blind. That means it has no through ventilation, no ventilation. So, what you are doing? You are giving compressed air or certain thing. Compressed air is the major source of ventilation in raises. So, and that is insufficient. It is very hot at deeper levels, very hot and humid, and that is why it is not comfortable. It is not safe also. People can fall sick and then cause accident also. So, what we do, that there are certain methods nowadays available, some mechanization has been done, very good methods, where what we do, that before making any raise, the raising is a procedure that that it starts from the bottom level and goes upwards. But before starting a raise, what we can do, we can make a center hole, which is a large diameter, maybe say 165 millimeter, center holes. we can make from the upper level. Instead of going from the lower level, we can make one from upper level to lower level. So, large dia we can make one large dia hole. What happens after you make the large dia hole, then you can start the raising from the bottom level. What happens, this large dia hole which is always existing throughout the raising process, that will provide ventilation, and the raise faster raising, raise will be much faster. So, that will give you more number of raises, and that will give the flexibility of increasing your productivity. So, faster raising, faster development, as I am repeatedly telling, is the essence of the faster production from stope and pillar method. So, in this particular drawing you must have seen that the raises are staggered. That means, one raise is here, one raise is here. This level between level 8 and 9, the position of the raises are like this, but between level 9 and 10 you see that the positions are staggered. Why? Because if I make raise below another raise, then the area will be more disturbed. So, what we do as a matter of common practice, and technically justifiable practice, that we stagger the location of the raises. That means, from 10th to 11th level, we again further make the staggered raises. That is for the stability of that area, that is for the stability of the entire area. Now, here you see that all drives and raises must be provided with supports. That means, this we must not forget, that we are heading towards stoping, but remember that all these drives and raises are the basic things. They are the basis of on which we are going to develop the stopes further to make the stopes. So, the drives and raises will not, when they are finished, they will not be immediately mined out. So, they will have some standing time, maybe years, maybe 1 year, 2 years, they will not be used. So, that they will have the conditions of the roof and sides will deteriorate. So, stop from all damage to this drives and raises, they all should be properly supported during the process of development, like the rock bolts or occasionally some timber props, ladders also, so that you can move through the raises whenever you require. To check also, occasionally you can send some people, some support experts, they will check the raises and see whether there is any problem with the roofs or the sides. All these raises must have chutes, that means the collecting mechanism, the ore collecting, the material collecting mechanisms, and they must have adequate protections, so that the haulage drives are free from any obstacles. So, whenever making a raise, that means you are sending material to the lower level, So, what is happening, that this material when falling on the levels, that will choke this level, that will not allow anybody to move. So, what we do, we make enough arrangements in the haulage drive in such a way that the haulage drive is free from any obstacles, that I will show how it is done. If the raises are not to be used immediately, as I said, it is never used immediately, very rarely it is done. So, barricades must be provided or may be provided at the bottom of for safety. So, if you are making one raise like this, then we can make a barricade here, so that any falling material will not come down to levels. So, that is essential for long term protection. You can keep one small door for movement of people, Now, see what these are the collecting chutes. Whatever you see here is the side elevation, and whatever you see is a cross section of the drive, where you see the mine car fixed on rail lines, and these are the chutes. So, if you operate this handle, then the material will fall into the mine car. If you close it, then the material is protected, or rather stopped there. So, whenever you want here, you can also manually operate it and open. There are some your wooden blocks are given here. So, whenever you open this these barricades, then material will fall on the cars. And in this case what happened, if you close this door, then the material will be stopped there, it will not come, and the line is free. When the material is filled, then the car can be taken away by locomotives. This is a practical, this is actual photograph of chute, wooden chute. These are wooden timbers, this is gate, and this these planks, wooden planks will stop the ore from flowing coming down to the next level. So, you can stop it by multiple number of wooden planks. So, once the raising is completed, then you can give a temporary barrier inside, some more wooden planks to stop and protect people who are moving in the drives below, they will not be hit by the falling rocks. So, that you can give some barriers at the end of the or at the bottom of the raises. So, these chutes are to be made, which can be reused also during stoping. So, if we properly made, then this will also keep the entire roadway or the haulage drive free of any obstacles, and these chutes, wooden chutes, can be reused when you are going for stoping. So, that these things are the preparatory part. You make the the drives, make the raises, support them, then make wooden chutes, and then after the cleaning up all the raises, all the materials are taken out, then you put a temporary barricade. These are the your basic requirement for the these things, your stope and pillar preparation. Now, you see that if you see it in section, you see that you have to make the raise. This is the raise that you are going to make. This is the raise. This is the raise from bottom level to the upper level. This is going upwards. This is going upwards, and this is in hang wall contact. This is in hang wall contact. Hang wall contact, that means beyond this there will not be any ore. This is waste material, and the ore will be in foot also. When you are taking raise in the hang wall, then ore will definitely remain in the footwall. This is the footwall side. This is the footwall side. Okay. So, if you take a section along the raise, it will look like this. So, this is the lower drive, this is the lower drive, and in between you have put the raise. The raise is in hang wall contact. That means, the hang wall contact is fully exposed. While raising, you see that the entire hang wall is exposed. You know that beyond this there will be no ore, and the hang wall is supported by rock bolts. These are rock bolts. These are all rock bolts. The rock bolts gives a support. So, with these things you prepare the these raises between levels ready for the stoping. So, in the next lecture we will be discussing how to mine out these raises, make the stopes, and how to make the wide stopes, how to keep the barrier pillars, rib pillars, and mine out safely. That we will discuss in the next lecture. Thank you very much.